Let's wrap up on tree representations. We've discussed explicit tree representations. Those are the ones where nodes are shown as points, um, squares, rectangles, whatever, and parent-child relationships are shown as links. You have usually the root node on the top, on the left, and the children going down or to the right. Implicit representations show parent-child relationships through not lines, not through lines, through, for example, containment, through overlap, through adjacency, icicle plots, tree maps, and so on. And we have hybrid techniques that try to combine the best of implicit and explicit tree representations. Now, these examples um, are the ones that you see here are axis parallel. So what is important here is that, as I said, that the root node is on the top and the children go to the bottom, or the root is on the left and children go like this, go horizontally. In the implicit one, again, we have squares that are all axis parallels, and it results in some artifacts that we've seen, and the same is true for hybrid ones. Now, these techniques solve from have the problem that the children get very small eventually, that you run out of space for showing your children if you stick to this top-down, left-right, outer, inner relationship. That's why polar representations of trees are more efficient if you have a lot of children, a lot of leaf nodes. Again, you can have explicit representations in polar layout. In node link diagrams, you can have the same for implicit ones by stacking your nodes outside instead of top to bottom. Remember what I said about the icicle plot that kind of bends into a circle. And again, there have been some hybrid approaches that are similar to the tree map that I showed you, but it's combining icicle plots and node link diagrams in some effective way. Now, to complete this overview, there are also some layouts that are free. Some of them I've been discussing earlier. In free layouts, you're not having any top to bottom, left to right, or center and periphery relation for your parent-child relationships, but it's kind of trying to make the most use of the space. So in the top, in the bottom left example here, this is kind of a force-directed layout that you can get from network and graph layouts, which tries to optimize the position of these nodes. So you can see you have some weird artifacts here. It's not clear which is your root node. This is a tree, so the root node could be any of these nodes. Intuitively, you would guess it's this one in the middle, but it could also be this one, because if this is the root node, then these are the children, and so on and so on. You follow these lines. So it's not always clear in this example what is the root node. However, it tries to make the most out of the space. Of course, you can always mark the root node and say, this is my root node, and you can use additional visual variables to show the depth of the branch, for example, the size of the node, the color shade, or whatever you want. Bubble tree maps are also kind of free layout. They're not necessarily axis parallel, as we've seen here in these tree maps, but they're more randomly aligned. And there are some specific map approaches, which I'm not going into detail now, which are inspired by maps to show trees, inspired by maps and, for example, political regions on maps. Now, as I said, there are tons of techniques. I invite you to have a look at treevis.net, which is a really nice interactive website that I have this high-level overview taken from: explicit, hybrid, axis parallel, polar, and free, and it has about 306 techniques on the website. You can use these kind of facets here to browse and to see specific types of trees. And you can see there are a lot of trees or techniques to show trees that I haven't mentioned here, which include like more representations inspired by nature, by real trees, three-dimensional representations, fractal trees, trees and matrices, and so on, and so on, and so on. So have a look at this. There is a small paper that comes with the website, which is called the Design Space of Implicit Hierarchy Visualizations, a survey. I couldn't find any other survey on trees so far, but the amount of techniques seen on this website clearly shows that there are many different techniques. Get some inspiration, look at the representations, try to figure out where do they work, where do they fail, what is good for my data set, um, and then try to make your own thoughts. It's, as always, hard. Thank you so much.